Well, hello students! Welcome to Mathematics Application class with me, Mr. Alfie. Today, we're going to learn about matrix. Have you ever heard about matrix? Let's check this video out. In our daily life, we always use number. Some of us use a lot of number every day. How can we deal with those numbers? Ancient Chinese mathematicians come up with arrangement to arrange number. Nowadays, we call the arrangements as matrix. If matrix hang together, we call it matrices. Matrices really are everywhere. They use in business, economics, cryptography, physics, electronics, computer graphics. One thing that makes matrices useful, we can pack so many information into them and then turn a huge problems into one single problem. So, to use matrices, we need to learn how they work. The matrices denoted with capital letter. For example, there's matrix A and there is matrix B. A and B in matrix A are elements of matrix A. K, L, M, N in matrix B are elements of matrix B. Matrix has size or dimensions. For matrix A, the dimension of matrix A is 2 by 1. You can write it like this example, A 2 by 1. What does that even mean? It means matrix A has 2 rows and 1 column, as you can see here. How about dimensions of matrix B? Dimensions of matrix B is 2 by 2. Because matrix B has 2 rows and 2 columns. Remember, always row by column. Turns out, we can treat matrices like regular number. We can operate them like add them, subtract them, multiply them, but we can't just divide them. That's the beauty of matrices. Okay. For addition, it's quite simple. We just need to add the corresponding element to another element in other matrix like 1 plus 5, 4 plus 6, 2 plus 8, and 5 plus 8. We can do addition in matrices if they have the same sizes or dimension. And we do the same for subtraction of matrices. For example, there are 2 matrices. The first rule is they have to be in the same size. So 2 by 2 and 2 by 2. Remember, and then you operate with subtraction with corresponding element. So 1 minus 2 equal to negative 1, 4 minus 3 equal to 1, 2 minus 1 equal to 1, and 5 minus 3 equal to 2. There are 2 types of multiplication in matrices. The first type is multiplication with scalar, and the second type is multiplication between matrices. In multiplication with scalar, you just simply have to multiply the scalar with each and every single element inside the matrix. So 2 times 1, 2 times 4, 2 times 3, and 2 times 2. This is the answer. So, how about multiplication between 2 matrices? The multiplication of matrices is not as simple as an addition. It's a unique process, or I call it like a pretty cool process. Multiplication between matrices, there's a condition that you need to check before you do the multiplication. So, for example, there's a matrix A, the dimension is m by n. It means the number of m represents how many rows in matrix A, and n is the number that represents how many columns in matrix A. And then there is matrix B. The dimension is P by Q. So P is the row and Q is the column. A and M can be multiple if and only if n equal to P. So the condition that 2 matrices be able to multiple if the number of columns in the first matrix equal to the number of rows in the second matrix. So, if n not equal to p, it means A times b is not defined. Let's say n equal to p. So, the product between A times b is AB. The dimension of AB is m by Q.